Or is it, what is it?
Sometimes they go very soft and then just blow up.
Oh,
Sir, are you okay?
wait, why? I don't know. I'm talking the same way I normally talk. I don't know.
No, you're not.
No, you sound like if you're sick or something.
Oh, wait. Let me. How can I increase the? I can't increase the mic sound.
Coronavirus.
Could be, dude. As a press from all the work you got. That's right, Zin. So don't, you guys shouldn't give me more work. All right, can you hear me?
Like we could hear
Yeah.
you, sir, but it's like you're. It sounds like you're really far or something like that.
The mic like is literally like any closer and like we'd be kissing.
We in your mouth, sir.
I put it in my mouth. We're gonna roar. Okay. Press the power button to increase volume. All right. Those are the bright ideas that Zion has to share. Okay. So let's begin. So first part of this test will be short answers, like fill in the blank, right? So I'm going to give you a statement. Obviously, you have to fill in the blank. Let me give you ideas, right? This type of class is used to form dynamic structures that can grow and shrink. What would you say?
Template class.
No.
Okay.
What was the question?
This type of class is used to form dynamic structures that can grow and shrink at runtime.
Linked list?
No.
Node type. Template node type.
Nope. Okay, Kevin is correct.
Pointer.
Kevin is correct. He chat. He put self-referential. True. This is a specialized form of a linked list where nodes can only be inserted and deleted from one end of the list. Stack. Yeah. What operations do you associate with a stack?
FIFO.
Push back.
Insert that from.
Push and move fast.
No, the actual official name
Push
for the
and
stack
pop.
operation.
Push and pop.
Push and pop. All right. Let's see.
Continue, sir. It's a good review.
I'm trying to figure out how to say these things without actually. All right. The pop operation, it removes a node from the bottom of the stack, deletes the memory that was allocated to the pop node, and returns the popped value. True or false?
False.
Repeat it one more time, please.
The pop operation removes a node from the bottom of the stack, deletes the memory that was allocated to the popped node, and returns the popped value.
False.
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 False. Yeah, that was it.
Okay, if you do insertion and deletion operations in a sorted array, now listen careful to what this is. I'm saying a sorted array. I didn't say linked list. In a sorted array, it can be time consuming. All the elements following the inserted or deleted element must be shifted appropriately. True or false?
False.
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 So let's repeat it. Insertion and deletion in a sorted array can be time consuming. All the elements following the inserted or deleted element must be shifted appropriately.
True.
True. Because I would have to sort it again.
Just think of it. I want you to imagine right now. It's not a linked list, right? So you can just add in the middle. It's an array.
It's an array of
So you cannot just all of a sudden like just add something in the middle and it keeps on going. So if it's a sorted array, let's say you have 10,000 numbers, right? And let's say you want to insert 957. Now you want to put 957. What's going to happen to all the like you find a point, right? Because it's sorted. You want to insert that value. What happens now when you try to place that? It's already occupied by another value. Yes or no?
Yes.
Yes.
So if you put 957
Time
the
comes.
location where it's supposed to go, what happens to the value that was in there previously?
It'll be replaced.
Gone. Replace.
You can't replace it though. I didn't ask you to replace it.
Then
Should be pushed back.
Push back where
Oh. So
It gets
insert.
we
shifted,
sort it
sir.
again.
it shifts to the right,
Depending
correct?
on
Yeah,
the
shift
value
to the
of
right
the
to
So what
make
happens to the
space.
one after that
Mhm.
one?
It also gets shift.
shift.
So that
shift.
means everybody from that point would have to be shifted. Yes or no?
Yeah. Yes, sir. That why working at
Yes.
array is complicated.
Is this efficient?
True.
No.
No.
No. So does that mean arrays are bad? Obviously not. It just means that
Just
you as
depends
a
on the
programmer have
problem.
to figure out, depending on your problem you're trying to solve, what is the most
Exactly.
appropriate data structure or solution to use. Some people get really attached to things that they like, and they don't want to use or try anything else because they say, I like arrays, man. I understand arrays. Link stupid. No. You have to be able to decipher what is the most appropriate structure given your needs and your problems. So in this case, an array would be a terrible choice, because if you had an array of 10,000 elements and it was sorted, and every time you insert, that means everything has to shift.
And be the programmer will solve every problem with one same solution.
Yeah. Okay. So
But sir, so stacks are common in test.
yes, stacks and queues will come on a test. That's why I need to finish this quickly so I can cover queues. But not in the sense that like code, but concepts. Like we talked about stack, it's you remove from the top, you add from the top. Same thing we're going to cover with queues. All right. So it's more like general concepts but not actual code. The code part for the test will revolve around linked lists. Okay, so true or false again. The elements of an array are stored contiguously in memory. True or false?
True.
True. That's how an array works. When you declare an array, the compiler goes and he allocates one solid chunk. That's why it's called contiguous memory, not pieces. So if you need 100 bytes, he's not going to give you 20, 20, 20, 20, whatever. He's going to give you one solid 100 bytes of memory. Since we've agreed it's contiguous, one contiguous block of memory, does that mean that you have immediate access to an array's element just because of that feature? Does that mean you have direct access? Like I can go to sub, let's say I can go to sub 200 instantly. True or false?
Yes.
Yeah. True.
Can anybody tell me why this is true, that I can just like jump to location 200 in an array like almost instantaneously? Why is that possible?
Is because of the indexes, sir?
Yes, but that doesn't really like how does an array allow me to jump to a location almost instantaneously? It's a definite benefit.
Because
why or how? Like, can you?
All of them have a set location, so you just know where every value there.
Okay, who said that?
Roy.
All right, Roy. So Roy is correct. So but let me God, I'm sweating like a pig. Hold on. So this is what happens when you have fur. So you guys are lucky. All right, I was meant to be born in some Scandinavian country, not the friggin' tropics, man. Hell. Okay. Hold on 1 second. People are coming into the class. All right, so let me quickly draw this thing for you. So let me share my beautiful screen. Let me just find this drawing program first. Correction to the, hold on 1 second. Correction to the correction, folks. I was in the right first time. Oh my God, such annoying. All right, sorry. What was I trying to do? Okay, share my beautiful screen. All right, let me close this off. Close this. All right, and okay, so you should see my screen now. Let me come here. I guess that work with that. All right, so now we have this whiteboard, so I can at least draw this thing for you so you appreciate the differences. I explained this actually when I was explaining linked list, but I think some people just probably never grasped it. Hold on, let me just let this program load up. All right. I need to get another laptop, man. Okay. Ooh, what the hell is this? Jeez. Jeez.
So you have to clean up after yourself, sir.
Mhm. All right, so let's look at this. So this is an array. Here. So this is. So this is an array. Now, so let's say this is 0 to 9. I don't know if it's 9. Just pretend. Just pretend it's 0 to 9, right? If this is an integer array, then the first thing compiler checks is, oh, it's an int array. How many bytes does an int take up on your machine? So on my machine, my architecture, we're going to say it takes up 2 bytes. On a different architecture, it might be 4 bytes. We don't know, right? So let's say it takes up 2 bytes. So this is an array of size 10. So if it's an int, so int cow size 10, that means it's an int array. There are 10 ints, so 10 times 2. I need a total of 20 bytes for this. So this is why it says it's contiguous. You get one solid chunk of 20 bytes in memory, not piece. You get one solid chunk of 20 bytes. Now, I asked you a question. I said, with an array, can I like almost instantaneously jump to a location? And the answer is yes. And the question was, why? Because if you look at this, let's say this was at location 100. Let's just make it simple. This is location 100. From here to here is 102, then 104, 106, 108, 110, blah, 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 right? 112, and so forth. My question is, so this is 0, 1, 2, 3, 4, 5. If I want to come here, right? If I wrote cow sub 5 is assigned 9. How long will it take for it to execute this? This is almost instantaneous. And my question was, why? What the freak? How am I already out of time? Anyway, sorry. So how is this possible that this is almost instantaneous? Well, if I know where the starting address is, right? So if the starting address, because every array has a starting address. So in this case, if this starting address is 100, then it's going to be plus 100 plus what?
Plus 2.
Why plus 2? If I said cow sub 5, right? Why is it instantaneous? Because of the word I chose to explain to this. It is, oh hell man, contiguous. It's contiguous. That means there's no gaps, right? So if the array starts at 100, I know each of these is 2 bytes, and I say go to cow sub 5, I know cow is the name of the array, and the name of any array is also the address of where that array starts in memory. So this is saying 100 plus what? 5 ints, right? How many spaces do 5 ints take? So it'll be 5 times 2. So it'll be 100 plus
10.
10. 110. So it takes you to the beginning of the 5th. Does that make sense?
Sir?
Yep.
That's why it's instantaneous, because once I know what the array is, I can just do a calculation. One calculation, start plus where you want to go, boom, I'm there. The problem is, let me tell you what the problem is with linked lists. This is why sometimes a linked list sucks and sometimes it's great. A linked list looks like this. This is a linked list. This could be at 100. This could be at 5,000. This could be at 25189. This could be at 300. This could be at 719. Do you see that these things are all over the place in memory? So you can't say, oh, you want to go to the third one, so it's going to be whoever the start guy is plus 3 times however big one of these nodes is. It doesn't work like that, because a linked list by nature is not contiguous in memory. That's the major difference between an array and a linked list. They're not contiguous. They give you the illusion. This is the key. It gives you the illusion it's a straight line, but it's actually not a straight line. It's scattered all over in memory. But because they're linked together, hence the word linked list or term linked list, it allows you to traverse it one node after the next. But it's not instantaneous. For you to get to this guy, you have to come to this guy. And for you to come here, you'd have to come here. So if I told you to go to the 10,000th element, you'd have to traverse from the first up to the 10,000. You can't just jump to it. So this is why linked lists do not, listen to what I'm saying, do not offer direct access. Any questions about that? Make sense? Okay. All right. Let me clear this again. And now we're going to look at, this is what I'm going to give you on the, so you're going to get questions like that. Okay. So those are the types of questions you're going to get for short and short answers and true false. Those types of questions. Now, what I'm going to give you next is something like this, right? I'm going to give you like this. So, let me draw it. So I'm going to give you something similar to this. I'll say, like this, like this, jeez, like this. All right, and let's say I call this P1, P2, P3, P4. All right, and let's say this is and call you is Bukut is good, but we don't have time to write all that long word. Okay.
Pause.
All right. So having said that, right? If I give you this instruction, I wrote so part of that question would be, I'll give you a diagram as you're seeing up here, right? You see this? I'm going to give you a diagram like this. And then I'll give you a line of code or lines of code. And I would say, what would be the diagram after that line or lines of code have executed? So with this starting diagram, what would this look like after this runs? This line runs.
P1 are linked with P3.
Say that again.
P1 will be linked with P3.
P1 will be linked to P3. Like, how would you draw it though? Like, how would you draw that?
Disconnect the P1 pointing to P2 and just point it to P3 instead.
So disconnect P1 from pointing here.
Mm-hmm.
So erase this.
Oh, not that. No, I'm thinking P1 another node with Aunt in there.
Okay, let me ask you a question, guys. Based on my diagram, right?
Mm-hmm.
What are these? These little rectangles represent what?
Nodes.
List nodes, right?
Yeah.
Okay. What are P1, P2, P3, and P4? What are those?
Pointers.
Nodes.
What are
You
they?
have pointers pointing to the nodes.
What
The
are
nodes.
P1, P2, P3, P4?
List node.
They're list nodes. P1 is a list node.
There's
They are list node pointers.
Mm.
List node pointers. You understand?
Mm-hmm.
Okay. Having said that, if I were to run this code, what would the diagram look like after it runs? Quickly, guys, come on.
P1 would point to
Would point to
P3.
So erase this. Is that what you're saying?
Yeah, yeah.
So you're saying
Then P3 would have, I mean, the
erase
third
this,
node would have
and
two
then
pointers.
Where
here,
P3 is pointing.
and then put what here?
P1.
P1.
How many people agree that this will be the diagram after this line runs?
I
How many
agree.
people agree? Come on, guys. How many people agree? You have to talk or say something. Okay. All right. So the answer is yes, it's correct. That is what it's going to look like. All right. Let's do another one. Let me go back to what the original looked like, just so we can see. So it looked like that. Erase this. Okay, so back to it. Now, forget that. So now what if I have I just threw you into deep water. Went from nice little.
I can't swim, sir.
I can't either. All right, but okay, having done that. All right, so now tell me what that's going to produce.
I think the first line, I'll put P3 to null.
No. You got to tell me what the final diagram looks like.
Oh, okay.
Because on the test, it's the final solution I want to see. What effect do those three lines in their totality have on the linked list? Hold on, let me turn on this fan, man. I'm cooking right now. Hold on.
I think is a point to P3.
Better not.
Okay, who'd like to tell me? What is it going to look like?
The same thing we do on a project, I understand it.
All right, let me just add these minions and then we can start. Almost there. Jacob says it's going to be circular. All right. Don't know if I can trust Jacob. All right.
Are you gonna like share your screen?
Yeah, share about the screen, sir. And what's it?
Oh, sorry, man. Sorry.
Yes, sir. You're well.
All right. Okay. So yeah, Jacob says it's gonna look circular. But we don't know if we can trust Jacob. So anybody else? Any other ideas?
1 second.
This is like a legitimate type of question you're going to see on the test. Like legit, I'm going to give you something like this. Like no surprises, just like this, but not like you're not going to see it exactly this. I'll just come up with some weird thing for you to do, and you have to tell me what it's going to produce.
I know the first line, I'll put P3 to the pointing to the null part of P4.
Okay. But I'm looking for the final outcome. Then I'm going to explain to you guys line by line.
The data
I think,
of P4 will be changed and will be set to mu.
Say that again?
The data of P4 will be changed and it will have mu
Okay, let me do this. I'm going to draw a copy of this thing.
I think
Draw a copy of this so we can work with the copy.
So is will be changed to mu. I think.
So
the last node will have 3 pointers and it will have
let
mule
me just do it like
inside.
this. So this is and
Yeah, that's right there.
now this is exactly why you have to understand this.
No, I think
Because
it would
if
have.
you don't understand it on the test, what the heck you're gonna do? And the test is timed, obviously. So if you think you're gonna share answers, by the time you discuss and say, wonder what this man wants or how you do this, you're killing time. Trust me. This is not like open all day, try to figure it out. It's not open all day at all. So you have a short amount of time. You can't figure it out. By the time your friend tries to explain it, they can't finish their own test. So, having said that, okay. So, what is it going to produce? Let me show you the first line.
Is will be changed to mu.
First of all, what kind of statement is this? First line.
Wow.
Come on, this programming one questions. Come on, stop wasting time.
Assignment, you did assignment to P3.
Who changes in assignment statement?
P3.
The left. So P3.
Yeah,
So I know for a fact, right, that when I'm done, who's going to be modified? P3. Now I have to figure out how he's going to be modified. So it says P3, which is currently pointing here, correct? So you're saying P3 should point to P1's next. So this is P1. You see it?
Yeah.
P1's next is the value in here. So now if I said P3 should point to whatever this guy's pointing to, he'd be pointing here. But I didn't stop there. I said P1 next. So he's basically saying, let's say this was 500. This was 500. What you're saying is P3 should point to this 500. So when I'm done, it's going to look like, that's what it's going to look like. Does that make sense?
Yeah.
Yeah.
This. Oh, frig. Okay. So this is gone, right? Then the next line says P1 is assigned P3. Right? Who did I move? Oh, frig. This is P1. So, sorry, P3 would come here. So this one will have to be erased. Right, but I erased the wrong one. So this would be erased. And then P1 here should be assigned P3. So now P1 comes here. All right?
Yeah.
And the last one says P4's data, this is P4's data, should get P2's next data. P2's next data is what?
Mu.
So now
Is
this
will be changed to mu.
become
Mu.
Any
Sir,
questions about?
Why did you move your P1 to there?
Yeah, my same question, sir.
The second line said P1 equal
Because
P3.
P1 is
Yeah.
assigned P3. So P1 should point to whatever P3 is pointing to.
It's a both that they point at the same thing.
So you move P3 in this line, right? In this line, you move P3 all the way here. Then after that, P1, stop pointing here, P1, point to whatever P3 is pointing. So here. P4 does not move. P4 data gets changed. All right?
Yeah, but the pointer still
Data
points up
gets
to
changed to whatever P2's next data is. This is P2's next. P2's next takes you here. His data here is mule. So now this becomes mule. Does that make sense?
2 mule.
Yeah.
So
that make
P3's data not change, right?
Yeah. Yes.
Any questions about that?
Sir?
Any questions about what I just did?
I have one.
Yes.
All right. For, P3, the data won't change, right? Even though P4 will have P3's data.
Say that again one more time.
I say for P3, since P4 have P3's data, the original P3 data not change, right? Yeah, still be the same.
This stays the same.
Okay,
So
all
they
right.
have two
Stays the same.
mules.
You're
Yeah,
just saying change P4's data. This guy is still
all
mu.
right. Okay, not the pointer itself then. Okay, all right.
Any questions? Anything else? Does it make sense?
Makes sense?
Okay, let's do another one, just so that this thing can hopefully be ingrained. All right, let me just erase that, and then that. So again, I gave you some true false. I give you some short answer questions that are very similar to what you should expect on a test. And then this section here will be just like what you're seeing right now. I'm going to give you just like this, and then I'm going to ask you to tell me what the diagram will look like after we do these manipulations, right?
Sir, my question. If we go to the PowerPoint, that'll help you with the test?
No,
Or
the test is exactly what I'm showing you here, and the PowerPoint doesn't cover this. The PowerPoint is just teaching you how a linked list is built, right? But if you understand how a linked list is built, then all I'm showing you right now is I'm just basically giving you
no,
a bunch of
for
operations, and then you just have to manipulate it.
I mean for the true and false things.
Oh, for the true and false, yes, 100%. For the true and false, going through the slides, especially at the end of the slides, there are short answers and there are bullet points, right? At the end of the slides, there are bullet points. Or in the ebook, sorry, the ebook, not the slides. The slides will help you, but the ebook on the chapter on data structures, there are bullet points. Review those, all right? And they're like short answer questions that you can look at, and those can help you with the first part of the test. And then this part, well, this part is just your understanding of coding, right?
Do we have an ebook for this class?
Yes, dude. It's on the course page.
Oh.
All right, so having said that, let's do another one. So let's do, oops. No, don't shout out the answer. I want everybody to try it first, because when you hear the answer, you kind of people turn dumb, right? We don't want to add to that already. There might be an issue because I'm not thinking this through, I'm just doing it. You might end up with an error. If there's an error, that's fine. The fact that you can recognize there's an error means you understand it, so that's fine. You just have to let me know if any of the lines produce an error or not, okay? All right, so tell me what that would produce. If I were to run that code. Once you're finished with this, there'll be no more practice for this, because obviously then you understand it. Then we can continue the rest of our class. Hopefully on a piece of paper and pen, you're trying to do this on your own. Let's see what the chat is saying. When the second line produce error. Yeah, I was thinking that too. Okay. I don't know if the second line produces an error. I didn't actually go through it when I was writing it out. So we shall see. All right. It very well could. But I'm going to wait till other people have tried it. Don't blindly accept what other people say. Remember, the only genius here is me. The rest of you are just like imitations. You're like fake. All right? You're like gold-plated necklace. I scratch a little bit and boom, plastic underneath. I'm just kidding, guys. I'm kidding. Actually, it's all right. Nobody's evaluating me right now, so during evaluations, will be different. I'm going to be really nice to you guys. I'll be like, class, do you have any questions? No? It's good. All right.
Use your British accent, sir.
Oh, I will, man. I will. Zoom user. I keep forgetting who Zoom user is. Is that Barry White? No.
That's right, sir. How did you know?
I was thinking to myself, that's how thinking usually works. All right. Thank you for adding to the yourself part. All right.
Anytime, sir. Anytime.
How the heck does P4 have a next? I don't know, brother. I do not know, dude. I just work here.
I can see that, sir.
Here we go. I'm about to explain this thing. Let's see if whatever diagram you have, right? If the nonsense you produced, is it truly nonsense or is it exquisite solutions? All right. I'm leaning more towards nonsense, but maybe you might prove me wrong. So here goes. You ready? Are you ready, minions? Because when I show you the solution, I don't want to do this a second time. Here we go. All right. First line. Let me use a rojo pen. Pluma roja. Okay. I'm speaking Mexican, by the way, guys. Mexican ain't a language, sir. Yes, it is. Okay, so let's look. All right. Now, normally in an assignment statement, the guy on the left changes. Now you're looking at this and going, who the hell is changing here? Well, let's see. P1 is not changing. I'm telling you that. P1 is not changing. You're saying P1's next. That's this dude.
P3 would change, sir.
Next is this. So what you're saying is P1's next. Next should be given what?
Oh.
Let me redraw it up here so we can look at the original and we can see what the new updated version looks like. All right? And don't lie to me. I want to know who actually got it correct. All right? Because I need to make fun of the people who got it wrong and I need to shame the people who got it right. Because
Well, just make fun of me one time, because I don't.
You screwed it up?
I'm pretty sure.
All right, that's good. That's good. That's what I like to hear. None of us like overachievers, damn it. And call rule is. So first thing, P1's next is this. next is this. So now the question is, what value do you want me to point to? Right now, this guy stores this guy's address, but you're saying, no, I don't want that anymore. I want you to store P1's next. So let me come here. P1's next is whose address? What value does this guy store?
So it's stored the one address.
So now this is gonna look like this. So don't lie to me. I need for people to spit out the truth out of their mouth, their bocas, right? Damn it. This is gonna look like ring. Who got that?
Yeah.
Yeah.
Yeah, sir.
Let me see how many people got that.
To
right?
point to itself.
I don't know
Point
how
to
many
itself,
people
yes,
got
sir.
that because some people lies, man. Okay. So that's the first line. Yeah, that's what the first line looks like. I think, because I didn't do it right, I didn't know what it's going to produce. I think this will create a lot of problems for the rest of the lines.
Yeah.
So let's see. Next line says P4's next. This dude. Okay.
No.
Right now, P4's next is null, right?
Yeah.
Thing. It should get P1's.
P1's. Yeah.
So this is gonna look like P1's next is
Gonna point
this
out
guy. It's gonna look like this. La 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 la. Boom! That's what it's gonna look like. Got it?
Sir, in the test we could actually give some stuff that makes sense to sir. Like what logical. Instead of like just to break the list like this.
No, it has nothing to do with logical. It has to do with, do you understand how to manipulate these things?
Alright.
Because if you understand how you manipulate it, you can tell when something is wrong or right. So it's not about how pretty it looks, because then you're going to be looking for patterns. Oh, it should look like this. It's not about how it should look. What does it actually do? If you understand it, then it doesn't matter what I give you. All right. Let me see if anybody's asking questions. No, sir wants to see us suffer. Yes, that is true. Unfortunately, I can't. But yes, that's why tests in person were much better because it was like 1 hour and 15 minutes of enjoyment. This one is different. I can only sense it online. Okay, so far done that. This one, P3 should get what? So what you're saying is, immediately when I look at this, I know that P3 should point somewhere. Okay, P3 should point where? P2's next.
So P2 next. So I change P3 to P2 next to P3.
So P3 will point to P2.
Who can tell me what that one will do? That's a tricky one.
And that the point to itself, so it won't refer to the next one.
Who can tell me what this line does? That's a beauty. Oh my God, that's a beauty.
You know, point P3 is next to P2.
Why P3 is next? I didn't say P3 is next. I said P3. So P3 should stop pointing here, right? Oh, the question is, where should he point to? What is P2's next? Let's say I just wrote this, right? I just wrote P2's next. If I said P3 has to point to P2's next, it would mean that P3 will point where? Here.
Yeah.
So then that's that. But then P2's next
is itself.
What?
Oh.
That's still itself.
Still itself, correct? So then this would point where? Okay.
That's breach. You got assigned the thing, so yeah.
And then the last one, P1's next data, P1's P1's next data
Call
should now become
P3.
P3's next data, which is
Call.
call. What changed?
Nothing.
Nothing. It remained the same.
Erase and write it again.
So this is the kind of thing you'd have to be doing on the test. Now, what will probably happen is that I'll probably have to give you a range of solutions, diagrams. I'll have to draw. It's going to be nasty to create this test. And then you have to pick the right diagram, I guess.
So the test is after the program set or before?
It's before, because the program set is due. Your program set is due when
Literally next week Tuesday, you say you?
what?
Your program set?
Thursday. You said
Tuesday.
Thursday.
Next
Due to
Thursday.
Next
The
Thursday.
test, the next Tuesday.
The test is Tuesday. But
Yes, sir.
this test, if you look at it, this does not require that you have to do the program set, right? Because these are things at this point you should understand.
Yes.
Sir, I have a question.
Yes.
I got lost with the first one.
With the first one.
Yeah. Like it says P1 next, which is cow. Like I mean P2, and then isn't P2 next?
So let me look at the original diagram. Hold on. Hold on. Here. P1s. Okay, P1s. Hold on.
P1 next.
Okay. P1. This is our original diagram. So P1's next.
So it will be
This is P1's next.
Uh-huh.
But if you do this again, if you do one more dereference, where does that take you? Yeah. Say if I just wrote, let's say I just wrote this. If I just wrote this, P1's next, I'm referring to this guy. What is this guy's value going to be? That's what I'm saying. What is this guy's value going to be? Well, I didn't stop there. Because we did another one of this, it says dereference this location. So that takes me here. Then specifically when I'm here, I'm saying is next. So that's why this whole line, this part here, is referring to this.
And that same logic you had to use to find the second to last node in the linked list. Next
Right.
step, next.
And then so then you're saying should be, so you're saying this value should be P1's next. Well, P1's next is this. What address does this guy have stored? This guy has the address of this guy. So you're saying this guy's address should be the same as this. So if this is pointing to this, you should point to yourself. Stop pointing here, and point to yourself. Does that make sense or no?
Yeah, a little bit.
Could you repeat it, sir?
Sir,
Yes.
sir, like in the previous example you gave.
I don't have that. Okay, yeah.
I know, but like the P3 was equals to P1 next, right? And we went to way to the P4.
You went way to the P4?
Yeah, because the answer was that P3 will be pointing at where is P4 as well.
Tell me the code. Let me write it again. I don't remember what it was. Tell me what is it?
P3 equals P1 next.
So now I know that this guy is going to change.
Mm-hmm.
Right? So he will stop pointing here. So you're saying point where? So P1's next is here. Just this. P1's next is this value. This is a number. Just think of it this way. Look at it. This is, let's say, 500. This is 500. Let's say 700. 700. is 900. Is 900. So you're saying P3 should get P1's next. If it just ended like that, P1's next, it'd be P3 should get 500, which is this guy's location. So P3 should point here. But we didn't stop there. This is referring to this. And because you have this arrow again, it says dereference one more time. If I dereference one more time, I'm here. But what part of this do you want? I want the next part, which is 700. Then that arrow says dereference one more time. So that takes me here. And what part of this do I want? The next, which is 900. So you're saying P3 should get 900. What's 900? It's this location. So when I'm done, P3 should point here. Does that make sense?
Yes, sir.
You have to like practice it.
And then and then for the one that we're doing right now, why would it stay at P2? Like it does like.
Hold on 1 second. Hold on 1 second. Okay. So your question was why what?
Like why would it still be like why would it point to P2? Because it just has two necks or something?
For which one? For which one?
For the one that we're doing right now.
Which line?
The first line, sir.
The first line.
line. Okay.
Yeah, still the first line.
Okay, so the first line. So now, P1's next is this guy, right?
Mm-hmm.
You didn't say for him to change. Because if I wanted him to change, I would just write P1's next. You didn't say that. You said P1's next. So P1's next is 500. But then since you have another arrow, it means the reference to 500. Okay, so I'm here now. When I'm here, it says this guy's next. So this is the part that needs to be changed. Because P1's next is this value here. But this value is not what I want because I put another next. So the arrow means the reference, right? So the reference takes me here. Once I'm here, the question is which part do you want, the data or the next? He says the next. So now this is saying this should change to what? It should change to P1's next. So I come back here to whatever P1's next is. P1's next is 500. So what you're saying is this 700 should now become 500. But if I change this to 500, then that means this bond is broken and his address is 500. So it looks like this, like he's pointing to himself. You confused? Confused.
Okay, sir.
Make sense, guys, or you guys are confused?
Sir, so for the test, if we get like the first line wrong, all the ones will be wrong, right? The other one?
Pretty much, yeah.
Mr. Rabani, when you say this, all these P's, all of them are pointers, right? Like P1 is pointer, but pointing to the first node, right?
P1, P2, P3, P4
are pointers, nodes, right?
Node pointers, yes. List node pointers.
Okay.
Yeah. Any other questions? Does it make sense?
Yeah, sir.
How would it cause an error, sir?
How would this cause an error?
Like as an example.
Oh, you want an example of an error?
Yes.
All right, let me give you an example of an error. So this is an example of an error, right? So I have this. I wrote this. The first line is already an error. Can you see why?
Yes, sir.
Why?
Because P4 is pointing to null. Another point to know
This
that
guy's next is what? Null,
Yeah,
right?
null. Yeah.
Yeah,
So
it also two next or something
if I
under
just
there.
convert this, just this part, right?
Mm-hmm.
This is the equivalent, because this is referring to this location. This is the same as me writing this. Null, arrow, next. That's exactly what you just wrote. This is what this is. Because this part, just this part, P4's next is this.
Okay.
This guy's null, right? So you're saying null's next. What do you mean null's next? So this is illegal. Your program would crash. Right there it would crash. So P3 can't do that. This is illegal. You have to tell me, oh, this you can't do that. Let's pretend that it didn't crash here. Let's pretend this was nice code, right? This is also illegal. Because what you're saying is P1's next is this. The reference again takes you here. You're saying this guy's data should be P4's next, again, null data. Again, that's illegal.
Sure. Would it give an error too, like if for the P4 you take away the data, just P4 next?
Just follow this over the road.
Which line?
For the second one, P1
one,
next.
if I did what?
Just follow this road.
If you remove data from the P4.
So if I remove data here,
Yes.
this would be an error. Why?
I'm asking like if it would
Yes,
be an
it
error.
would be an error because you're saying in the data portion of P1's next, in this part, you're saying in this part, right? P1's next data here, put an address, right? You can't put null in there because this guy's expecting data. Addresses go in this portion, in this portion, in this portion. You're saying put an address in a data portion.
Okay, sir.
Any other questions? Okay, let me just quickly go
So
over.
you I use
Huh?
Prev too? You I use Prev or just one next?
No, no prev, no prev.
Okay.
Let me see something. Prev. Would I use prev? No, no prev. Okay, so having said that, let me just quickly talk about queues. So a queue is like a linked list or restrictions. Whenever you think of queue, think of like a waiting line, right? So this is a bank, these are tellers, right? When you come into the bank, right? You can't just go up to the front of the line unless it's empty. So if there's somebody here, and then somebody else here, and somebody else, you come in, and let's pretend these are busy, right? Busy, busy. That means you have to come here. Can't come here, here, here. You have to come there. That's how a queue works, all right? A queue works, it's called FIFO. First guy in is the first guy who leaves. That's why people who want to go to the bank go really early in the morning, because the first guy who's in the line will be the first guy who's processed, which will be the first guy who gets to leave, which is the opposite of a stack. The stack is the last guy who enters the stack will be the first guy that comes out. So that's how a queue works. Just think of it like a regular line that you've seen in the real world. So every time a new person comes in, they get added to the back. So if I were to compare a queue to a linked list, which operations from the linked list match up with the operations from a queue?
Insert that block and remove from.
No, you don't insert that front. How do you get when you get added? Where do you get added?
Remove from back.
You get added to the back. So the function that would stay from the list would be insert at back. But where do you get removed from?
Front.
The front.
From
So the
front.
two functions I would keep would be remove from front and insert at back. And the official functions for queues are, it's called NQ, which means insert, and DQ, which means remove. So for a stack, this would be called push. For a stack, this would be called pop. A stack is a LIFO, a queue is a FIFO. A list, linked list, would use, a stack would use insert at front, remove from front. A queue would use insert at back, remove from front. All right? So those are the functions that you would see. Any questions about this?
No, sir.
So that's your that's your test on Tuesday. Thursday, your program is due. But again, I guarantee you by doing that program set, you will be sufficiently prepared for the test. So this class will end in less than a minute.
Sir, we'll do coding as well for the test.
No, the test is exactly what I explained to you. Like literally that what I showed you.
Like no coding, like for us to put.
No, you'll see, like, I'll give you lines of code and I just tell you draw it, or show me what the diagram is that it's going to look like, or tell me what I would see printed on the screen. But you don't have to actually write code.
Oh, okay then.
But test 2, yes.
What's the when is the next quiz, sir?
The what?
When is the next quiz?
Next quiz will be probably next week Thursday.
Okay.
Right after the test, sir?
No. The test is Tuesday. The test is Tuesday.
That's all right. Then our quiz will be next Thursday.
Oh yeah. Of course, yeah. I thought you meant like same period. Yeah. Quiz is
Golly.
easy. Quiz is easy. Don't worry. Trust me.
Will be in class.